What is the main problem that the proposed method of long context in context learning aims to address in the field of language models and deep learning?
The main problem that the proposed method of long context in context learning aims to address in the field of language models and deep learning is the challenge of efficiently utilizing large quantities of data for training without the need for extensive fine-tuning. Specifically, the paper focuses on understanding the properties and effectiveness of in-context learning over long context lengths, where traditional short context models face limitations due to context length restrictions. By exploring methods such as naively prompting the base model, retrieving relevant examples for each test example, and comparing to fine-tuning, the study demonstrates that as the number of demonstrations in context increases to extreme values, the behavior of in-context learning shifts. Long context in context learning becomes less sensitive to example order and benefits from retrieval over using a random set of demonstrations, allowing for the use of a single set of demonstrations encoded once through the model. This approach provides insights into the efficiency and performance trade-off between many-shot in-context learning and fine-tuning on the same data, offering a strong alternative to traditional methods in utilizing large datasets for training language models.
How does the proposed method of long context in context learning work, and can you illustrate it step by step based on the details provided in the paper?
The proposed method of long context in context learning works by considering various approaches to utilizing a large dataset for in-context learning. Firstly, the performance of prompting the base model naively is evaluated. Then, examples are retrieved to be used in context for each test example. This retrieval process involves using a BM25 retriever to find the most relevant demonstrations for each test input text. The method also involves comparing the performance of in-context learning to fine-tuning the base model on varying amounts of data from each dataset. As the number of demonstrations in context increases to extreme values, the behavior of in-context learning shifts, becoming less sensitive to example order and less reliant on retrieval over using a random set of demonstrations. The effectiveness of long context in context learning is attributed to the retrieval of more relevant examples rather than continual refinement of a decision boundary during encoding. The method also highlights the impact of grouping examples of the same label on the effectiveness of long context in context learning. Additionally, the study shows that long context in context learning can outperform fine-tuning on the same model, especially when dealing with a large number of examples in context.
What are the theoretical or practical benefits of using long context in context learning compared to traditional fine-tuning methods?
The theoretical and practical benefits of using long context in context learning compared to traditional fine-tuning methods include the ability to achieve high performance with a large number of examples in context, surpassing the performance of fine-tuning models on the same dataset. Long context in context learning becomes less sensitive to example order as the number of demonstrations increases, allowing for more efficient encoding and caching of demonstrations for inference. Grouping examples of the same label strongly impacts the effectiveness of long context in context learning, suggesting that contextualization of examples with different labels is crucial for performance. The effectiveness of long context in context learning is attributed to the retrieval of more relevant examples rather than continual refinement of decision boundaries during encoding. Additionally, long context in context learning offers a strong alternative to retrieval and fine-tuning in certain data regimes, showcasing its versatility and efficiency in handling large quantities of data for various tasks.
How was the method of long context in context learning validated or tested in the experimental setup described in the paper?
The method of long context in context learning was validated and tested in the experimental setup described in the paper through a systematic study that considered several key aspects. Firstly, the performance of prompting the base model naively was evaluated. Secondly, examples were retrieved to be used in context for each test example. Thirdly, the method was compared to fine-tuning the base model. Lastly, models trained to adapt to longer contexts were utilized for comparison. The study found that as the number of demonstrations in context increased to extreme values, the behavior of in-context learning shifted. It became less sensitive to example order, and the benefits of retrieval over using a random set of demonstrations diminished. The effectiveness of long context in context learning was attributed to grouping examples of the same label and the retrieval from more relevant examples, rather than continual refinement of a decision boundary during encoding. The experimental setup involved comparing the performance of in-context learning across several variants of Llama 2 to 7b adapted for long context lengths, as well as considering other models like Mistral 7bvo. 2. The evaluation was conducted on 5 classification datasets, and the performance was measured using accuracy and macro F1 metrics. The study also utilized constrained decoding to ensure valid labels as output and subsampled 250 examples from the test set of each dataset for evaluation. Additionally, the study compared in-context learning with random sampling, retrieval, and fine-tuning methods to assess the effectiveness of long context in context learning in various scenarios.
What specific results were achieved with the long context in context learning method in terms of performance gains and accuracy improvements mentioned in the paper?
The specific results achieved with the long context in context learning method in terms of performance gains and accuracy improvements mentioned in the paper include the following. 1. Performance continues to increase past 2,000 demonstrations, with accuracy gains of up to 50. 8 points, averaging 36. 8 points across the 5 datasets. 2. Long context in context learning becomes less sensitive to example order, as the number of demonstrations in context increases to extreme values. 3. Retrieving relevant examples for each test set example outperforms using a randomly selected subset, especially in the short context regime. 4. The effectiveness of long context in context learning is attributed to retrieving more relevant examples, rather than continually refining a decision boundary during encoding. 5. The importance of carefully selecting in-context examples diminishes as the number of examples in context increases, allowing for the use of a single randomly selected set of demonstrations with minimal performance penalty. 6. In the long context regime, using a single randomly selected set of demonstrations is more feasible, with a performance penalty never exceeding 5 points of improvement and as low as 1. 8.7. In comparison with fine-tuning, in-context learning with hundreds or thousands of examples is effective, with performance generally outperforming fine-tuning on the same model, especially when a relatively small set of examples is available. 8. Fine-tuning performance never exceeds long context in context learning performance, even with additional examples, except for specific datasets like TREC and TREC Fine. 9. The paper suggests that in some scenarios, fine-tuning on 4096 examples may still be preferable to prompting with 1000 if efficiency of inference is a major priority. 10. The study demonstrates that long context in context learning is a strong alternative to retrieval and fine-tuning in certain data regimes, showcasing its effectiveness and potential for performance improvements.
What are the limitations or drawbacks mentioned in the paper regarding the long context in context learning method when compared to parameter-efficient fine-tuning strategy like LoRa?
The limitations or drawbacks mentioned in the paper regarding the long context in context learning method when compared to the parameter-efficient fine-tuning strategy like LoRa include the higher computational cost of inference over many thousands of tokens in long context in context learning. This cost can be steep, making the efficiency and performance trade-off between many-shot in-context learning and fine-tuning complex. Additionally, in the long context regime, using a more computationally efficient but less effective strategy of a single randomly selected set of demonstrations is more feasible, but it may result in a performance penalty of up to 5 points of improvement compared to fine-tuning. Furthermore, The paper highlights that fine-tuning has a higher upfront cost but allows for reduced inference time cost, which can be a drawback when considering the trade-off between the two methods. Despite the effectiveness of in-context learning with hundreds or thousands of examples, the paper suggests that this amount of data is also suitable for fine-tuning a model, indicating that fine-tuning may still be preferable in some scenarios due to its reduced inference costs.